Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be discussing Section 2 of Chapter 4, Systems of Linear Equations, and we are going to focus on solving systems through a method called substitution. So, systems can be solved in three different ways. So far we've learned how to graph systems and find the point of intersection. Now we're going to use the substitution method to solve our system without using any pictures. So the best way to see how substitution works is to go ahead and look at some examples. So let's jump into problem 1, number 1. So our first problem says, what is the solution of the system? Use substitution. Our two equations are y equals 3x and x plus y equals negative 32. To use substitution, we need one of our equations to be solved for one of the variables. In this case, the first equation is already solved for y because y is by itself. So to use substitution, what we're going to do, we're going to plug what y is into the other equation. So my other equation, I'm going to keep the x plus, and I'm going to replace y with what y equals. According to the first equation, y is equal to 3x. And then I'm going to keep copying that second equation, which says it's equal to negative 32. So all I'm doing is replacing y from the first equation into the second equation. And then simplify your answer. X plus 3x is 4x. And then divide both sides by 4 to find that x is negative 8. Now, like any other system we've done so far with graphing, we always had two answers, the x and the y value. Same thing with this. So once we find the x value, we also need to figure out the y value. So you can use either equation. I like to go back to the one that's already solved for, and we're going to plug in our answer for the variable. In this case, we found x, so we're going to plug it back in to y equals 3x. So y equals 3 times negative 8, which is negative 24. So when I write my final answer, I have to write it as a point. My x value always coming first. My y value always coming second. So my solution to this system is negative 8, negative 24. Our second problem wants to know what is the solution of the system. Use substitution. This time our two equations are y equals 2x plus 7 and y equals x minus 1. So in order to use substitution, one of my equations has to be solved for a single variable. In this case, the first equation is solved for y. Y is by itself, so I'm going to plug in what y is into the second equation for y. So what I'm going to do, y equals x minus 1, I'm going to replace y with what it equals from the first equation, 2x plus 7, and set that equal to x minus 1, just finishing copying that second equation. Once I've plugged in for my variable, I then need to solve the equation. So first I need to get the x's on the same side. So I'm going to subtract x to get x plus 7 equals negative 1, and then subtract 7. So x is negative 8. Once I have figured out the first variable, I'm going to plug it back into either equation to simplify the second. So for me, x equals negative 8, I'm going to plug it back into that first equation, y equals 2x plus 7. And all I'm doing is plugging in the x and simplifying. So y is 2 times negative 8 plus 7. 2 times negative 8 is negative 16 plus 7, and that's negative 9. So once you have your x and your y value, plug them in to your point. X comes first, followed by your y value. So our solution for number 2 would be the point -8, -9. Our third example, what is the solution of the system? Use substitution. This time our equations are y equals 6x plus 7 and 3x minus 8y equals 4. So again, for substitution to work, the variable, one of them has to be solved for itself. In this case, y in the first equation is by itself. So I'm going to plug it into the second equation. So I have 3x minus 8. And I'm going to replace y with what's in the first equation, 6x plus 7. And that's equal to 4. So I'm just using these two together. Replace y with what we know, and then simplify. So this would be 3x minus 48x minus 56, because I have to distribute that 8, equals 4. Combine my like terms. This would be negative 45x minus 56 equals 4. Add 56. Whoops. This would be then negative 45 x equals 60. And then divide by negative 45. Come on, pen, cooperate. There we go. Now, 45 does not go into 60, but I can divide both of these by 15. So I'm going to simplify my fraction. Yes, these we will not always get whole numbers. Just like with graphing we didn't. It was just easier with graphing because the calculator did most of the work for us. So we'll be left with x equals 60 divided by 15 is 4. Negative 45 divided by 15 is negative 3. So in this problem, x is negative 4/3. So once I have one value, I'm going to plug it back into either equation. Again, I usually go for the one that's already solved for. So in this case, that's y equals 6x plus 7. I'm plugging in for x. So let me slide over so you can see this a little bit better. This would be 6 times 4 over negative 3 plus 7. Whole number times a fraction, just multiply the top numbers. Don't change the denominator. Simplify that to negative 8. And negative 8 plus 7 is negative 1. So when I get that x is negative 4/3 and y is negative 1, my final thing to do is write it as a point. What was x? I moved my negative to the top of the fraction. It's still the same thing if you leave it on the bottom. And y was negative 1. So my final answer to this problem would be at negative 4/3, negative 1. Our next problem, what is the solution of the system? Use substitution. This time we have x equals y plus 6 and x plus y is 10. So again, for substitution to work, one of your equations, you need a variable by itself. In this case, x is by itself. So I'm just going to plug it into the second equation. So I'm replacing x with what it is, y plus 6, and then copying the rest of that second equation like I see it. So plus y equals 10. And then simplifying. 2y plus 6 equals 10. Subtract 6. So 2y equals 4. And then divide the 2. So y is 2. So once you solve for one of your variables, plug it back in to either equation you started with. I, again, usually go for the one that was already solved for. So x equals y plus 6. And plug in your variable. Y is 2. So 2 plus 6 tells me that x is 8. Now be careful writing your final answer as a point. X comes first. X was 8. Even though we found it second, you got to go xy for your points. 8 and then 2. So our solution would be 8, 2 for this problem. And our last example for today, what is the solution of the system? Use substitution. We have y equals 2x minus 1 and 2x plus 3y equals negative 7. So again, for systems to work, you have to have one of the equations solved for a variable. In this case, the first one solved for y. So we're going to plug that into the second equation. So we have 2x plus 3. I'm replacing y with what the first equation says, 2x minus 1. And I'm keeping equals negative 7. I want to solve this equation and simplify. So I'm going to need to distribute the 3. So we'll keep 2x. 3 times 2x is 6x. 3 times negative 1 is negative 3. And that equals negative 7. Combine our like terms. We have 8x minus 3 equal to negative 7. Add 3 to both sides. Let me move this up a little bit. When I add 3 to both sides, I'm going to be left with 8x equals negative 4, which I'm then dividing by 8. Make sure you're simplifying your fractions. So in this case, x would be negative 1/2. So once you've figured out one variable, we just need to plug it into one of the original equations. Doesn't matter which one. Again, my go-to is the one that's already solved for. So y equals 2x minus 1 is what I'll use. And I'm just plugging in my newly found answer for the variable x. So this would be 2 times negative 1/2 minus 1. So again, whole numbers times fractions, you just multiply the whole number with the top, so that's negative 2. Don't change the denominator, 2 minus 1. Negative 2 over 2 is negative 1. Minus 1 tells me this is negative 2. And we were solving this for y. So y is negative 2. X is negative 1/2. So if we put this all together as a point, we're at negative 1/2, negative 2. That is where these two lines would be intersecting on a graph. So this concludes our lesson on being able to solve equations, systems of equations through substitution. If you have any questions, please ask Ms. Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Ms. Brooks.